I'm going to demonstrate the transistor cutoff region, forward active region, and its saturation region. How we will understand in which region the transistor is, we can understand from this 2 digital multimeter. This is my power supply, and you can see there is like 5 volt. It just supplying 5 volt into here, and this multimeter is connected to the transistor collector and emitter, and then I can see the collector emitter voltage from this multimeter, and this multimeter is connected to see the base voltage. This is the potentiometer I have connected across this power supply, and then you can see currently if I turn this potentiometer, it just showing properly its range from 0 volt to the power supply volt, and you can see the power supply volt is 5 volt. So I'm moving to 0 volt for this potentiometer, and then I'm gonna apply this 0 volt to the transistor base. Please don't shut off. And then now I have already applied 0 volt, nearly 0 volt to the transistor base. So the base voltage of this transistor is like 0.05 volt. So at this stage the transistor is showing the collector emitter voltage is nearly to the power supply voltage. This is 1.2k resistor. I have set up this one for protecting the transistor current. It just limits the transistor current, as this is not going to damage or something. Okay, so now I'm increasing this base voltage, and then I'm gonna see the region of these transistors in this display. So currently this is in cutoff region surely, because this is just showing approximately the power supply voltage is a 4.9 volt. Here is like 4.98 volt as well, like just very subtle difference. So we can see this is showing the power supply voltage. As soon as I increase this base voltage, and you can see this is gonna be decreased, because the current will flow from collector to the emitter as soon as I change the base voltage from 0 to little bit up. So you can see from 0 to 0.6 volt, and there is a like big change. It just drops from 5 volt to 1.3 volt. That means the transistor turn to the forward active region from its cutoff region. So the forward active region, the condition of the forward active region is the collector emitter voltage will be greater than 0.2 volt. So you can see there is greater than 0.2 volt. That means this transistor is now on forward active region. So what happens if I just increase the base voltage? You can see I'm gonna move this transistor from its forward active region to its saturation region, increasing the base voltage. That will move to saturation region. This is increasing the base voltage. It just in saturation, because the collector emitter voltage is less than 0.2 volt. So this transistor is now in saturation region. You can see there it is less than 0.2 volt. So forward active region to the saturation region. In saturation region, very interestingly, it just displaying another properties. You can see there is a collector, base, and this terminal is emitter. So before it goes to the saturation region, it was in reverse biased. The collector base junction. What biased are now, if I just turn this one from the ground to the base, you can see this collector base is just in forward bias, NPN. So it's showing this is like in forward bias. In saturation, by itself it turns to forward bias, the collector base junction. That's very interesting properties of a transistor. So in what happens if this transistor turns to in forward bias, the collector base junction, the current which generally flows to the base, this now base to the emitter, this one fraction of current from the base is just turning to the collector as well, because this is now in forward bias. So the current now just coming this side as well, one fraction of current. So this fraction of current is just reducing the beta value. So, and that's why this in saturation region, the transistor is just showing less beta value than its forward active region, because one fraction amount of current IB is just divided two parts. One is going to the base emitter, another is going to the base collector. That's why the IB is separating, and then it just reducing the function, amplification function of the transistor. So the transistor is in saturation region. I'm moving this from base to the emitter. When this is in forward, you can see when this is in forward active region, you can see the collector base junction is in reverse biased. You see, no minus sign, in reverse biased. And then when I just put this one in saturation region, it just come to the forward bias. That's very interesting for a transistor. That's why it just comes from its forward active region to its saturation region. So in conclusion, I'm showing you again the saturation region, forward active region, and then the cutoff region. So you can see this in saturation, this is the highest point of this saturation, and that's why the transistor is just passing a huge amount of current from its collector to its emitter. As soon as I goes down the base voltage, and then it just moving from its saturation region to its forward active region